Hello, everyone. Tonight we're diving into the story of an asteroid that could have ended civilization as we know it, and the astronomers who almost missed it entirely. Picture this. It's the 19th of June, 2004, and astronomer Roy Tucker is sitting in his cramped office at the Catalina Sky Survey in Arizona, squinting at yet another batch of grainy telescope images on his computer screen. He's been doing this routine work for years, canning the sky for moving dots that might be asteroids, most of which turn out to be harmless chunks of space rock that will never come anywhere near Earth. But tonight, something different catches his eye. A faint smudge of light is moving against the background stars, and when Tucker measures its trajectory, his coffee goes cold in his hand. So, if you enjoy exploring mysteries and the unknown, please take a moment to like and subscribe, but only if you truly enjoy what I am saying here, and let me know where you are tuning in and what time you are tuning in the comments. It's always fascinating to see people from all over the world joining us. The object Tucker has just discovered will eventually be designated 99,942 Apophis, named after the ancient Egyptian serpent god of chaos and destruction. And as it turns out, the name is disturbingly appropriate. The mainstream scientific consensus today holds that Apophis is a near-Earth asteroid approximately 340 meters in diameter. That might not sound particularly impressive until you realize that an object this size traveling at cosmic velocities carries the kinetic energy equivalent of about 880 megatons of TNT. For perspective, the largest nuclear weapon ever detonated by humans was the Soviet Tsar bomber at 50 megatons. Apophis packs the punch of 17.5 Tsar bombers, all concentrated in a solid chunk of rock and metal hurtling through space at 12.6 kilometers per second. Tucker's discovery wasn't immediately recognized as the potential civilization it would later prove to be. In fact, the asteroid was initially catalogued as a routine near-Earth object and given the prosaic designation 2004 MN4. It took several more months of observations before astronomers realized they had stumbled upon something genuinely terrifying. The discovery process itself reveals just how precarious our planetary defense systems really are. Tucker was using a relatively modest 1.5-meter telescope, not exactly cutting-edge technology even by 2004 standards. The Catalina Sky Survey operates on a shoestring budget, relying on automated systems to scan broad swaths of sky and flag potentially interesting objects for human review. It's a bit like trying to spot a single black ant crawling across a football stadium from the cheap seats while wearing sunglasses at night. Here's a quirky detail that most people don't know. Apophis was actually discovered twice. Tucker spotted it, first in June 2004, but then astronomers lost track of it for several months. The asteroid was independently rediscovered in December 2004 by a team at the Siding Spring Observatory in Australia, who initially thought they had found a completely different object. It wasn't until researchers compared the orbital data that they realized both teams had been tracking the same asteroid. This near miss in detection highlights a somewhat embarrassing gap in our cosmic surveillance network. You're still occasionally losing track of potentially dangerous asteroids for months at a time. The early orbital calculations for Apophis were based on a frustratingly small number of observations. In astronomy, determining an asteroid's precise trajectory requires tracking it across multiple positions over an extended period. It's like trying to predict where a baseball will land after seeing only the first few milliseconds of its flight. The initial data suggested that Apophis was following an orbit that brought it relatively close to Earth every few years, but the exact details remained maddeningly uncertain. What made Apophis particularly challenging to track was its relatively small size and dark surface. The asteroid reflects only about 23% of the sunlight that hits it, making it roughly as reflective as a charcoal briquette. Spotting such a dark object against the black background of space requires exceptional observational conditions and a good deal of luck. Some researchers have ventured into academically debated territory by suggesting that there might be thousands of similar-sized asteroids in Earth-crossing orbits that we simply haven't detected yet. Our current survey programs are estimated to have found only about 40% of potentially hazardous asteroids larger than 140 meters in diameter. This means that right now, as you are listening to this, there could be dozens of Apophis-sized objects out there that we know absolutely nothing about. The naming of the asteroid provides its own interesting subplot. When 2004 N4 was first catalogued, it received the temporary designation that follows standard astronomical conventions. But once its orbit was confirmed and it was assigned a permanent number, 99,942, Discovery Team had the honor of suggesting a name, Roy Tucker, along with his colleagues, David Tholen and Fabrizio Bernardi chose Apophis, after the Egyptian god, also known as Apep, the serpent of chaos, in Egyptian mythology. Apophis represented the forces of dissolution and destruction that constantly threatened to unmake the ordered world. The choice of name turned out to be eerily prescient, though the astronomers couldn't have known just how appropriate it would prove to be. The discovery of Apophis also coincided with a broader awakening in the astronomical community about the reality of asteroid impact threats. The 1990s had seen several high-profile discussions about near-Earth objects, partly inspired by movies like Deep Impact and Armageddon, but also by genuine scientific concern, following events like the 1994 impact of Comet Shoemaker-Levy 9 with Jupiter. However, most of the focus had been on much larger objects, see so-called civilization killers, that might be several kilometers across. Apophis represented something different, a merely city killer that was small enough to have escaped detection but large enough to cause regional devastation if it hit a populated area. Remember how Roy Tucker's discovery seemed like just another routine asteroid detection? Well, that comfortable assumption lasted exactly until the 27th of December, 2004, when astronomer Steve Chesley at NASA's Jet Propulsion Laboratory ran the updated orbital calculations and watched his computer screen display a number that made his blood run cold. The probability of Apophis impacting Earth on the 13th of April 2029 had just jumped to 2.7%. That might not sound like much, but in the world of asteroid impact probabilities, 2.7% is absolutely astronomical. For comparison, your odds of being struck by lightning in any given year are about 0.0003%. Apophis was suddenly looking 9,000 times more likely to hit Earth than you were to get zapped by a thunderbolt. The mainstream scientific protocol for assessing asteroid impact threats uses something called the Torino scale, which runs from 0 to 10 and was designed to help communicate the level of concern to both scientists and the public. A level 0 means no hazard. The asteroid will definitely miss Earth or is too small to cause damage. A level 10 represents a certain collision with a global catastrophe potential. Most asteroids that astronomers track score a comfortable 0 on this scale. Apophis initially scored a 4, the highest rating ever assigned to any asteroid at that time. Level 4 on the Torino scale is defined as a close encounter meriting attention by astronomers with a 1% or greater chance of collision capable of regional devastation. The last time any celestial object had warranted such attention was never. Chesley's calculations triggered what can only be described as the Crane's community. Conference calls were hastily arranged. Observing schedules at major telescopes around the world were suddenly reshuffled. The European Space Agency's Space Situational Awareness Program went into high alert mode. For the first time in human history, astronomers were seriously contemplating the possibility that they might need to recommend evacuation of entire cities based on the orbital mechanics of a space rock. Here is where things get deliciously ironic. The more precisely astronomers tried to pin down Apophis's orbit, the more uncertain everything became. Each new observation slightly refined the orbital parameters, but those tiny refinements had enormous implications for the 2029 encounter. A difference of just a few meters per second in the asteroid's velocity could mean the difference between a harmless flyby and a catastrophic impact. It's like trying to predict exactly where a golf ball will land after seeing only the first inch of its flight from the tee. The uncertainty wasn't just academically frustrating, it was practically terrifying. NASA found itself in the unprecedented position of having to plan for a potential asteroid impact without being able to say definitively whether one would actually occur. Emergency response protocols were quietly dusted off and updated. Theoretical evacuation scenarios were modeled for major population centers. International cooperation agreements for planetary defense were suddenly elevated from academic exercises to urgent practical consideration. But here is a quirky detail that demonstrates just how bizarre the situation had become. Some astronomers were secretly hoping for more definitive bad news. The logic was perverse, but understandable. Apophis were confirmed to be on a commission course. At least it would have 25 years to do something at it. The worst-case scenario wasn't impact. It was continuing uncertainty right up until the last moment. By early 2005, additional observations had refined the impact probability down to about 2.4%, but this was still horrifyingly high by astronomical standards. The asteroid's orbit was becoming better understood, but that understanding only highlighted how precarious the situation really was. Apophis follows what's called an Aten-type orbit, which means it spends most of its time closer to the Sun than Earth does. This orbital pattern brings it back to Earth's neighborhood roughly every 7 to 8 years. But the 2029 encounter was shaping up to be special. The gravitational interaction between Apophis and Earth during the 2029 flyby would fundamentally alter the asteroid's future trajectory. Depending on exactly how close the approach turned out to be, Apophis could be nudged into a variety of different orbits, some of which would bring it back for another close encounter. In 2036, some researchers ventured into academically debated territory by suggesting that the 2029 flyby might represent a kind of cosmic roulette wheel. Earth's gravity would essentially roll the dice on Apophis's future trajectory, with the outcome determining whether the asteroid would become a periodic threat or be deflected into a safer orbit. The mathematics involved were staggeringly complex, requiring supercomputer simulations that modeled gravitational interactions down to the level of individual meters. The international response to the Apophis threat revealed both the strengths and weaknesses of humanity's space monitoring infrastructure. On the positive side, observatories around the world quickly coordinated their efforts to gather additional data. The Arecibo radio telescope in Puerto Rico was enlisted to bounce radar signals off the asteroid, providing precise measurements of its size, shape, and spin rate. European astronomers contributed off the asteroids. Japanese researchers joined the tracking effort. For the first time, the global astronomical community was truly working together on a planetary defense problem, but the coordination also highlighted significant gaps in our capabilities. Most of the world's major telescopes were designed for deep space astronomy, not for tracking fast-moving objects in the inner solar system. The existing survey programs were adequate for finding large asteroids years in advance, but they struggled with smaller objects like Apophis that might provide only decades of warning. As 2005 progressed, the Apophis situation began to resemble a slow-motion thriller. Each new observation had the potential to either raise or lower the impact probability, and astronomers found themselves in the surreal position of hoping their own measurements would prove their worst fears wrong. The asteroid became the subject of intense scrutiny by both professional and amateur astronomers, with observers around the world contributing data to refine its orbital parameters. The psychological pressure on the scientists involved was enormous. They were simultaneously trying to might be tracking humanity's potential destroyer. Remember that 2.7% impact probability that had NASA scientists losing sleep. Well, by late 2005, additional radar observations and refined calculations had brought some relief. The impact probability for 2029 had dropped to essentially zero. The 2029 flyby wouldn't just be a near-miss D, would fundamentally reshape Apophis's future, and whether that future included a collision with Earth in 2036 would depend entirely on whether the asteroid passed through a gravitational keyhole just 600 meters wide. The mainstream scientific understanding of grass-tanning keyholes represents one of the most elegant and terrifying concepts in orbital mechanics. Imagine Earth's gravity field as an invisible three-dimensional landscape of hills and valleys extending out into space. As Apophis approaches in 2029, it will follow a specific path through this gravitational terrain. If the asteroid passes through one particular narrow region, a keyhole, Earth's gravity will nudge it into a slightly different orbit that brings it back for another close encounter in 2036. And that second encounter might not be a near miss. The keyhole itself is remarkably small, only about 600 meters across, roughly the width of 6 football fields. That sounds reasonably large until you realize that this target zone exists in three-dimensional space at a distance of thousands of kilometers from Earth's surface. It's like trying to thread a needle while riding a roller coaster in the dark. If the needle were the size of a small town and the thread were a mountain-sized chumpaners per second. Here is where the story takes on an almost surreal quality. The fate of human civilization might depend on Apophis's trajectory being accurate within a few hundred meters across a distance of millions of kilometers. The precision required is equivalent to shooting a basketball from New York and hitting a specific parking space in Los Angeles. The gravitational keyhole was first identified by researchers at NASA's Jet Propulsion Laboratory, using sophisticated computer models that simulated millions of possible trajectories. The calculations revealed that if Apophis passes through this narrow gravitational cavity, Earth's gravity will accelerate the asteroid by exactly the right amount to set up a collision course for the 13th of April, 2036. If it misses the keyhole by even a few hundred meters, the 2036 encounter becomes a harmless flyby. The discovery of the keyhole scenario introduced an entirely new level of complexity to asteroid threat assessment. Previous impact predictions had been relatively straightforward. Either an asteroid was on a collision course, or it wasn't. But Apophis presented a conditional threat that depended on the precise details of a future gravitational encounter. It was like being told that your house might burn down, but only if a specific coin flip 7 years from now comes up heads. Some researchers ventured into academically debated territory by suggesting that the keyhole scenario might be more common than previously thought. The idea is that many potentially hazardous asteroids might exist in similar conditional states, where future impact probabilities depend on the precise outcomes of near-miss encounters. If this hypothesis is correct, then the Apophis situation might not be unique, but rather the first example of a whole new category of asteroid threat. Here's a quirky detail that demonstrates the bizarre precision of modern orbital mechanics. Bat astronomers can predict exactly when and where Apophis will be visible during its 2029 flyby. On the evening of the 13th of April, 2029, observers in Europe, Africa, and Western Asia will be able to see the asteroid with the naked eye as a fast-moving star crossing the constellation Pisces. It will appear as bright as a third Magnitude star and will traverse the entire sky in about an hour. For most people, this will be the first and possibly only time they'll ever see a potentially dangerous asteroid with their own eyes. The 2029 encounter will provide an unprecedented opportunity for scientific study, closer than the orbit of many geostationary satellites. At this distance, even modest, ground-based telescopes will be able to resolve surface features on the asteroid. Sumo-based instruments will have a field day mapping Apophis's composition, structure, and rotation. In exquisite detail, the flyby represents a natural experiment that will advance, but the scientific opportunity comes with a psychological cost. The 2029 encounter will be a dramatic reminder of humanity's vulnerability to cosmic impacts. Millions of people will look up at the sky and see a potentially dangerous asteroid passing closer to Earth than our own communications satellites. It will be a visceral demonstration that we live in a cosmic shooting gallery and that our planet's safety depends on the precise trajectories of countless space rocks. The keyhole scenario also highlighted serious limitations in our ability to predict asteroid behavior over long time periods, while astronomers can calculate Apophis's position with remarkable precision for the next few decades. Small uncertainties in our knowledge of the asteroid's properties, its exact mass, shape, and surface characteristics accumulate over time. These uncertainties are amplified by the Joukowsky effect, a subtle force that causes asteroids to drift in their orbits due to uneven heating by solar radiation. The effect is tiny, typically changing an asteroid's orbit by only a few meters per year, but over decades. This drift can accumulate to distances larger than the gravitational keyhole itself. Predicting whether Apophis will pass through the keyhole requires understanding not just its current trajectory, but also how that trajectory will evolve under the influence of solar radiation pressure, gravitational perturbations from other planets, and potentially even outgassing if the asteroid contains volatile that pushes the limits of our most sophisticated models. The international response to the keyhole discovery was swift and decisive. The European Space Agency began planning a mission called Don Quixote, designed to test asteroid deflection techniques. EXA accelerated development of its own planetary defense programs. The Japanese space agents JOXA contributed expertise from their asteroid sample return missions. For the first time, major space asteroids or series lead aiming to develop the capability to also. For Japanese space a major space ages multi-take. Remember that tiny 600-meter keyhole that could determine humanity's fate? Well, the good news is that by 2013, improved radar observations had definitively ruled out the keyhole passage. Apophis will miss that gravitational sweet spot entirely, which means the 2036 impact scenario is off the table. But here is what makes the 2029 flyby absolutely extraordinary. Even without the threat of future collision, this encounter will be the closest approach of a large asteroid to Earth in recorded human history. On the 13th of April, 2029, yes, a Friday the 13th, because apparently the universe has a sense of humor, Apophis will streak past our planet at a distance of just 31,068 kilometers from Earth's surface. The mainstream scientific consensus describes this as an exceptionally rare event. To put that distance in perspective, it's closer than many of our own satellites. The asteroid will pass beneath the orbital altitude of geostationary communications satellites, which circle Earth at about 35,786 kilometers. For a brief few hours, Apophis will literally be flying through humanity's satellite infrastructure, threading the needle between our GPS constellation. It's like having a 340 meter with a cosmic bullet pass through your backyard while you are having a barbecue. The visual spectacle will be unlike anything any living person has ever witnessed. Staving around sunset in the eastern Atlantic, Apophis will appear as a bright, fast-moving star visible to the naked eye. The asteroid will cross the entire sky in just a few hours, traveling from the Atlantic Ocean across Africa and Europe and into the Asian continent. Observers with binoculars will be able to clearly see its motion against the background stars in real time as cosmic freight train racing across the heavens at apparent speeds faster than most aircraft. Here is a quirky detail that demonstrates just how close this encounter really is. During its closest approach, Apophis will be moving across the sky at about 42 degrees per h. That's faster than the moon appears to move, which takes about 24 hours to cross the same angular distance. If you point your finger at the asteroid and hold it steady, Apophis will drift away from your fingertip in just a couple of minutes. The gravitational effects of this close encounter will be dramatic and scientifically invaluable. Earth's gravity will accelerate Apophis from its approach speed of about 5.9 kilometers per second to a departure speed of roughly 10.4 kilometers per second. The asteroid will gain approximately 50% more kinetic energy during its brief visit to our neighborhood, energy stolen directly from Earth's orbital motion around the Sun. Of course, the amount of energy involved is so tiny compared to Earth's total orbital energy that our planet won't even notice the difference. But for Apophis, the encounter will fundamentally reshape its future trajectory through the solar system. The 2029 flyby will also subject Apophis to tidal forces unlike anything it has experienced in millions of years. Just as the moon's gravity creates ocean tides on Earth, Earth's much stronger gravitational field will create stress patterns throughout the asteroid structure. Some researchers have ventured into academically debated territory by suggesting that these tidal forces might be strong enough to trigger landslides, crack formation, or even structural reshaping of the asteroid. If Apophis is what's called a rubble pile, a loose collection of rocks held together primarily by gravity, the encounter might cause significant changes to its internal structure, or even break off small fragments. The scientific observation campaign for the 2029 flyby will be unprecedented in scope and Apophis, with every available ground-based and space-based telescope. The Goldstone Deep Space Communications Complex in California will bounce powerful radar signals off the asteroid, creating detailed three-dimensional maps of its surface with resolution down to a few meters. The European Space Agency's ground-based telescopes will contribute optical observations. Amateur astronomers around the world are organizing coordinated observation campaigns. Even the Hubble Space Telescope will be enlisted to study how the encounter affects the asteroid's rotation. But perhaps the most ambitious scientific response to the 2029 flyby comes in the form of dedicated space missions. NASA has proposed sending multiple spacecraft to rendezvous with Apophis during its Earth encounter, riding along with the asteroid as it experiences our planet's gravitational field. These missions would provide a front-row seat to observe how tidal forces affect a near-Earth asteroid. The data collected could revolutionize our understanding of asteroid structure and behavior during close planetary encounters. The Chinese Space Agency has announced plans for their own Apophis mission, and the European Space Agency is considering options for piggyback observations using existing deep space assets. For the first time, a single asteroid encounter will involve coordinated observations by virtually every major spacefaring nation on Earth. Here is what makes the timing particularly fascinating. The 2029 flyby occurs during a period when humanity's space-based infrastructure is more extensive than ever before. We'll have multiple space telescopes, numerous planetary missions, and possibly even crewed stations beyond Earth orbit by the time Apophis arrives. The asteroid will be flying through a region of space that's increasingly crowded with human technology, providing obsolescent Apophis arrive. The encounter will also serve as a real-world test of our planetary defense monitoring systems. More the theoretical protocols and international cooperation agreements that have been developed since Apophis was first discovered will be put into practice. SAM networks will be tested, peer-to-peer sharing agreements will be exercised, emergency response procedures will be evaluated under actual conditions, albeit with the comfortable knowledge that this particular asteroid will disseminate. The psychological impact of the 2029 flyby shouldn't be underestimated. For millions of people around the world, the 13th of April 2029 will mark the first time they've ever seen a potentially dangerous asteroid with their own eyes. The experience of watching a mountain-sized chunk of rock sail past Earth closer than our own satellites will drive home the reality of asteroid threats in a way that no amount of scientific documentation ever could. It will be humanity's cosmic wake-up call, delivered courtesy of a space rock named after the Egyptian god of chaos. Remember watching that mountain-sized space rock sail past our satellites? Well, the 2029 Apophis encounter didn't just provide an unprecedented astronomical spectacle. DEEC accidentally launched the most comprehensive planetary defense program in human history. The main scientific consensus High-Burrow, NASA's darted mission, launched in November 2021, was a direct response to lessons learned from the Apophis. Scare the double asteroid redirection test successfully smashed a refrigerator-sized spacecraft into the asteroid moon Dimorphos at 6.1 kilometers per second, changing its orbital period by 32 minutes. It was humanity's first successful demonstration that we could actually nudge an asteroid off course if we needed to. The mission was conceived, funded, and executed specifically because Apophis had shown us how vulnerable we really were to cosmic impacts. The European Space Agency's Hera mission, scheduled to launch in 2024, will follow up on DART's impact by conducting detailed studies of the crater and debris field. Together, these missions represent a $300 million down payment on planetary survival, TEA's first serious attempt to develop practical asteroid deflection capabilities. China has announced their own asteroid deflection mission, targeting the near-Earth asteroid 2090's Zelenfriven Lufis. Russia is developing Kenik Impactuactic Techmilies and private companies like Spanning. Apophis didn't just wake up the space agencies, it woke up the entire world. Here's a quirky detail that demonstrates how thoroughly Apophis has infiltrated popular culture. The asteroid has been featured in over 40 science fiction novels, 3 major Hollywood films, and countless video games since its discovery. The irony is that the real Apophis never actually threatened extinction. At worst, it would have caused regional devastation comparable to a large volcanic eruption, but its cultural impact far exceeds its actual destructive potential. The technological developments spurred by Apophis research extend far beyond asteroid deflection. The monitor the asteroid have been adapted for satellite collision, to collation, precisions, orbital modeling tech, refined during the keyhole. Calculations have improved spacecraft navigation throughout the solar system. Computer simulation methods developed to predict Apophis's behavior are now used for climate modeling, earthquake prediction, and even financial risk assessment. Sometimes the most important discoveries come from threats that never materialize. Some researchers have ventured into academically depraved view. As our detection capabilities improve, we're likely to discover many more asteroids in similar size ranges that pose conditional or probabilistic threats. The international protocols developed to handle the Apophis situation, information sharing, coordinated observations, joint mission planning, may become the template for managing dozens of similar situations over the coming decades. The economic implications of the Apophis legacy are staggering. Government spending on asteroid detection and deflection technologies has increased by over 2,000% since 2004. Investment in space-based manufacturing and mining operations has been partly justified by their potential dual-use applications for planetary defense. Insurance companies now routinely include asteroid impact scenarios in their risk models. The growing space economy owes a significant debt to a 314-meter chunk of rock that scared us into taking copic thrux. The scientific data collected during Apophis observations has also revolutionized our understanding of small asteroid populations. Detailed radar studies revealed that Apophis is likely a contact binary, 2 separate rocky bodies that gently merged at some point in the distant past. This discovery suggested that many small asteroids might have similar structures, which has important implications for deflection strategies. You can't necessarily treat every asteroid like a solid bowling ball, when some of them might be more like cosmic snowballs held together by weak gravitational forces. The international cooperation fostered by the Apophis situation has created lasting institutional changes. The United Nations formal asteroid threat assessors now maintains a formal asteroid threat coordination center. The International Asteroid Warning Network facilitates real-time information sharing between observatories. The Space Mission Planning Advisory Group coordinates potential deflection missions between space agencies. These organizations exist today because Apophis taught us that asteroid threats require global responses, not national ones. Looking toward the future, Apophis will continue to provide scientific value for decades to come. The asteroid returns to Earth's neighborhood approximately every 7 years, with notable approaches in 2036, 2044, and 2051. Each encounter offers opportunities for additional study. Tracking the long-term evolution of the asteroid's orbit and physical properties, by 2051, we'll have nearly half a century of detailed observations of a single near-Earth asteroid, an unprecedented datation that will inform our understanding of how these optics behave over time. The 2029 flyby will also serve as a crucial test of our planetary defense systems. And a really 29 flyby, while we know Apophis won't hit Earth, the encounter will exercise every aspect of our detection, tracking, and communication networks. It's like conducting a massive fire drill for the entire planet, ensuring that when we eventually face a real impact threat, all our systems will function smoothly under pressure. Perhaps most importantly, Apophis has fundamentally changed how humanity thinks about its place in the solar system. Before 2004, asteroid impacts were largely viewed as geological curiosities, interesting events that happened in the distant past or far future. Apophis made the threat immediate and personal, transforming abstract statistics into visceral awareness that we live in a cosmic to visceral awareness that we live in a cosmos to front our permanent awareness, and in doing so, catalyzed the development of technobladian. In doing so, Apophis never actually threatened to destroy civilization, but in the process of not destroying us, it accomplished something perhaps even more remarkable. It forced humanity to grow up, cosmically speaking. We learned to work together across national boundaries when faced with threats that transcend earthly politics. We created institutions and protocols that will serve us well when the next potentially dangerous space rock comes calling tonight. As you settle into sleep, remember that Apophis is still out there, following its carefully calculated orbit around the Sunday, gradually approaching its date with destiny in 2029. When that Friday the 13th arrives, something no generation in human history has ever seen, and potentially dangerous at less time than it takes to fly from New York to London. It will be a reminder that we inhabit a dynamic, occasionally dangerous universe, but also a celebration of human ingenuity and international cooperation. The cosmic serpent of chaos, as it turns out, taught us how to become planetary guardians, and in teaching us that lesson, Apophis transformed from humanity's potential destroyer into one of our most valuable teachers. Sweet dreams, knowing that we're a little bit safer tonight than we were before a small telescope in Arizona spotted a moving dot among the stars.